when we speak.
Sorry.
Gestures are, when we speak, we spontaneously produce gestures, even when we're not really thinking about visually communicating. And I'd like to share this example to set the common ground. So this is a recording from an experiment in which the person is talking about something abstract. So he was trying to explain the meaning of the phrase, disclose something confidential. Here, even though what he's talking about is abstract, he produces gestures that metaphorically represents abstract ideas. So he will present information as a manipulable object. So he's going to do gesture like this to show that he's holding an idea or information, and then he will move his hand away from his body to show that the telling can be conceptualized as movement away from the body. So let's look at these examples.
Is to tell people something that is supposed to be a secret that you're supposed to keep to yourself, and just share it with others. Is to disclose something confidential.
Right. So these examples tell us that even when we are not, so we know that the people gesture quite a lot when people talking about movement of objects or people's action. But even when people talking about quite abstract concepts, people use these depictive, iconic or metaphorical gestures to show how they're conceptualizing these ideas. And so today I'd like to make sort of two claims about these gestures that we just saw. So gesture is a window into the speaker's mind. By looking at the gestures, we gain extra information that you wouldn't be able to get if you only listen to the speech. So that's one point. And the second point is that the gestures can influence the gesture's cognition. So gesture doesn't just communicate information to the audience, but gesture actually changes something in the gesturer's mind. And when you think about gesture's relation to thinking and speaking, I need to get so when we think about gesture's relation to thinking and speaking, there are two aspects to this relationship. One is what I call the mechanism, and the other one is function. And so what are these two things? And function has two aspects: communicative function, so gesture can communicate information to the audience, but also gesture has self-oriented function, a cognitive function, which influences gesture's own cognition. And today, I'm going to focus on the mechanism and the self-oriented function of gestures. And so mechanism is the process that generates gesture, and then function is the sort of cognitive consequence of producing a gesture. And in terms of mechanism, Ozyurek and I have proposed the interface hypothesis, how gesture is produced. And then in terms of self-oriented function, with Alibali and Mignon Chu, we proposed a gesture for conceptualization hypothesis in 2017 paper. And basically, I'm going to give you an overview of these ideas today. And I think it's really important to have an integrated theory of the mechanism and function so that we have a holistic understanding of the whole process from mechanism to the consequence, generation mechanism to the consequence. So let's talk about mechanism first. So this is the model as Ozyurek and I proposed, and it's a complex figure, but I will walk you through it. So the left-hand side is the gesture production system, and right-hand side is the speech production system. And so this green part is sort of a classical speech production system. For example, Leifeld, 1989, the book Speaking proposed something like this. So the discourse model represent what has been said, and by the speaker and also by other participants in the conversation. And based on what has been said, you generate the message to be in, what communicative move is necessary in the next utterance, and this communicative move needs to probably have speech and gesture. That's why there are two arrows. And then you retrieve whatever propositional information that is relevant to the next utterance and generate a message. You retrieve words that are appropriate, create a syntactic formulation, retrieve relevant phonemes, and then speech is generated. And then at the same time, so-called the action generator generates the idea for the message for the gesture, and the sort of ingredients for these ideas for gesture comes from spatio-motoric representation in the working memory. And sometimes you have to take environment into the account. So especially this is obvious when you're pointing to something in the environment. You need to know where things are. But also we know that the audience, spatial configuration of the audience is also important in how we produce gestures. That's the sort of gesture stream and the speech stream of the production model. And one important feature of this is that there is a feedback from formulation, message generation, to the action generator. So action generator generates idea for gesture based on how speech is formulating the idea for verbalization. And so this feedback is one important feature, and another important feature is that this action generator is a general purpose action generator outside of the speech production process. So it's a process that generates also practical action, like a grasping a cup to drink. So it's a general purpose action generator, but when you're talking, you generate action for communicative purposes. Right. So gestures are generated from this general purpose process outside of the speech production process, but it's tightly linked to the speech production process. So for example, speech formulation can shape gesture generation. And I'm going to provide evidence for these two key features of the model. So the action generator for both communicative action and practical action. So if gestures are created in this general purpose mechanism, then gestures should exhibit properties of practical actions, like drinking water from a cup. And in order to investigate this hypothesis, we ask this question: is gesture production affected by the affordance of the reference object? So affordance is a sort of technical term in psychology, which means that the objects invite certain actions. So that's affordance. Object inviting a particular action, that's affordance of the object. And we're interested in whether this influences gesture production. So we asked participants to describe how to rotate the left mug into the right mug. So typically people would say something like, you turn the left mug 45 degrees to the right, or something like this. These are kind of things people say. And we manipulated the affordance of the mugs, whether or not they invite grasping. So in the other condition, we showed spiky mugs like this, but the task is the same. Spikes are irrelevant to the task, because the task is to describe the rotation necessary to align the two. And what we saw is that this spike manipulation actually has impact on the gesture production frequency. So the y-axis is the number of gestures produced per minute, and people produce more gestures when they're describing rotation of smooth mugs than spiky mugs. So even though spikes are irrelevant to the task, whether or not these mugs invite grasping had an impact on how much people gesture. When objects are inviting you to grasp, then they produce more gestures. So what this means is that the gesture production process is sensitive to affordance of objects. That means, so this supports the idea that these communicative gestures are actually generated from this more general purpose mechanism that also controls practical action. The second important feature is that there is a feedback from speech production process to the action generator. So speech to gesture influence. Okay, speech shapes gesture. And one demonstration of this is how spatial information is packaged into clauses in speech. That shapes how people produce gestures. So for this aspect, we looked at manner and path in motion events. So when you're describing an event like this, where a cat is rolling down the street because he has a big bowling ball inside his stomach, manner is the rolling action, and then path is downward trajectory. And the way, so different languages use different grammatical structure to describe this. So if you're speaking English, you have a very compact description like this. He rolls down the street with one clause, which is controlled by the verb roll. But if you speak in Japanese, you need more complex, grammatically complex structure. You need two verbs, one for roll, the other one for to descend. So korogatte, saka o kodaru. And if you speak in Turkish, you need very similar grammatical structure with two verbs, one for roll, the other one to descend. And this grammatical structure, these two grammatical structures matter because psycholinguistic literature has shown that the clause is an important speech production planning unit. And we, roughly speaking, convert our ideas into words, clause by clause. So if you're speaking Japanese or Turkish, you need two processing cycles to express manner and path. But if you're speaking English, one processing cycle is sufficient to verbalize two ideas. And our idea was that these processing cycles are reflected in gesture. So we classified gesture depicting this scene into three types: manner gesture that only shows rotation, path gesture that shows going from point A to point B, and then manner path conflated gesture shows both pieces of information simultaneously. And what we found was that the English speakers predominantly use manner path conflated gestures, so they can conceptualize manner path in one processing cycle for speech, and that information packaging is reflected in gesture. For Japanese and Turkish, they need two processing cycles, and they tend to use manner gestures and path gestures to express these two pieces of information separately in gesture. And I'm going to skip all the quantitative analysis, but show you three videos to illustrate the key findings. So here's a typical English speaker who has one close description, and she has a single gesture to express the two ideas.
He rolls down a street into a bowling alley. He rolls down a street into a bowling alley.
And here's the Japanese speaker. Here's a Japanese speaker who uses two close description and separates the two ideas into two separate gestures.
こうなんか回転しながらボールみたいに転がり落ちていって、こうなんか回転しながらボールみたいに転がり落ちていって。
Next, Turkish speaker, a similar grammatical construction, and again, gestures are separated. Gesture separates man and path into two movements.
Yuvarlana gidiyor. Yuvarlana gidiyor.
So what this shows is that the action generator actually gets information from the speech formulation process, and it changes the information packaging for gestures. So we looked at two studies. So first study showed that the action generator is outside of the speech production process. It's a general purpose one, which is also used for practical action. And then the second study on cross-linguistic comparison showed you that linguistic formulation process has an impact on action. So those are two key features of the interface model. And next, I'd like to talk about function, specifically self-oriented function of these gestures. So the mechanism part told us that there's a conceptual level link between gesturing and speaking. So what this means is that the gesture must have something to do with conceptualization. And because it's a conceptual level link, we can infer that the gesture has impact not just for speaking, but also thinking more general. And our proposal is that the gestures have four cognitive functions. Gesture activates, manipulates, packages, and explores spatio-motoric representation for thinking and speaking. And spatio-motoric representations is roughly, it's almost the same as image. Or you could call that like a simulation of spatio-motoric events and action. So I consider these like three terms to be more or less interchangeable. So first, let's look at the evidence that the gesture activates spatio-motoric representation. So there are two kinds of activations. One is boosting representation that is already active versus generating new spatio-motoric representation that wouldn't be there otherwise. So we look at two studies that will support both ideas. Okay. So what's the evidence for boosting existing representation? So gesture boosts mental simulation of physical movements.
İşte herkes lafı vardı Nida'nın ağzında. Oku burada dedik Boğaziçi ya da Koç'ta. En iyi öğrencisi.
Okay, can I continue? Yeah. So in order to investigate this idea that the gesture boosts existing activation, we asked people to solve this problem. Gears are arranged in a horizontal line. If you turn the gear on the far right clockwise, to which direction will the gear on the far right turn when there are four gears? And the figure on the screen is for your benefit. So our participants didn't have this figure. they just heard this auditorium. And then if you give this problem to people, they would normally simulate the movement of the gears. So they would go like, okay, first one goes this way, the second one goes, third one goes. Okay, so it's anti-clockwise. Now that's, for example, the way people usually solve this problem. But what's interesting about this problem is that there are two ways of solving this problem. One is to simulate movement of each gear, but also another way is to simply judge whether the number of gears is odd number or even number. And that will tell you whether it will go to the other direction or the same direction as the first gear. So that's more like a mathematical solution. And right. So these are simulation strategy and parity strategy is this mathematical strategy. And if you solve this problem, if a university student solve this problem 4, 5, 6 times, they will realize that, oh, I don't need to actually simulate. I can just, think about the number of gears. Okay. And so they will usually shift from simulation strategy to parity strategy. Right. So if gesture boosts the activation level of the mental simulation, then with gesture, people should stick to the simulation strategy because that gives you the correct answer. And if gesture supports it, it's easy to do it. So they will keep doing the simulation strategy. Consequently, the people should be less likely to find the parity strategy, the mathematical strategy. So half the participants were prohibited from gesturing. So they were sitting on the hands. They were sitting on the chair, but also they were sitting on the hands so that they cannot move their hands. In the gesture allowed group, we didn't say anything about the hands, but just about everybody gestured. And what we looked at is the dependent variable is whether or not they found the parity strategy within 6 strands. And whether or not you gestured made a difference. So y-axis is proportion of participants, and the left-hand bar is the allowed people in the allowed condition. Right hand is the gesture in people in the prohibited condition. And the different colors indicate different types of people. So green people found the parity strategy, and the red people stuck to the simulation strategy throughout. And what you see is that you have a bigger red part in the allowed condition. So what that means is in the people in the allowed condition, more of them stuck to the simulation strategy. So, and then gesture prohibition led to higher likelihood of parity strategy, finding the parity strategy. So what this tells us is that the gesture boosts imagery of object movements that they had already because everybody is using a simulation strategy. We can know that from their verbal protocol because people are asked to think aloud. So we know from the verbal protocol, they were generating these images and gesture boosts this imagery. And then that has influence on the course of thinking during problem solving, whether or not you switch to a different strategy. So that was evidence for boosting existing representation. So how about evidence for activating new representation? So for this, we investigated how gesture influences people's processing of linguistic metaphor. So metaphor allows us to understand abstract ideas based on concrete spatio-motoric imagery. And so in order to understand metaphor, you need to somehow activate spatio-motoric imagery that would underlie the metaphor. So in English, there's a phrase like to spill the beans, and this means disclose something confidential. And the underlying metaphor is that the beans are secrets, and spilling is telling the secrets. So we were interested in whether gestures can improve metaphor processing, and we inferred that especially left-hand gestures must be important because left hand is mainly controlled by the right hemisphere. And then if you move the left hand, then the right hemisphere of the brain gets stimulation, and that should facilitate the metaphor processing in the right hemisphere. So one thing I forgot to tell is that we know from brain imaging studies and patient studies that the right hemisphere of the brain is crucial for metaphor processing. Therefore, left-hand gesture should improve metaphor processing. So we manipulated which hand is available for gesturing, and we measure the quality for metaphor explanation. And so we assess the quality for metaphor explanation by counting number of metaphorical mappings people can actually explain. So beans represent secrets, spilling represent telling, and also how explicitly they make these statements. So basically each metaphor or each explanation was coded as either 0 or 1 or 2. And this is the manipulation. So we asked people to hold one of the hands on the table, and the other hand was used for gesture. And in this particular experiment, we encourage people to gesture with the free hand so that we can equate the gesture frequency for the right hand free condition and left hand free condition. If you don't encourage people to gesture, then right hand free condition will have a higher frequency. But in this particular experiment, we managed to equate the frequency gesture rate for right hand free condition and left hand free condition. And the explanation, the quality of explanation was actually affected by the gesture. So the y-axis is the explanation quality, which spans from 0 to 2. And left-hand gesture condition was the best. It's significantly better than no gesture condition. And the right-hand gesture condition is statistically somewhere in the middle. So the metaphor processing is better when producing gestures, and only for the left hand, that was the case. The way we interpret this is that the left hand gesturing activates imagery in the right hemisphere of the brain, and that imagery is used for metaphor processing. So here, I think this is an evidence that the gesture can activate new spatio-motoric representation that wouldn't be there otherwise. So gesture can do two kinds of activation, activating new information and also boosting existing imagery. So that was the activation function. The second one is manipulation function. So gesture helps manipulate spatio-motoric representations. So what's the evidence for this? So we looked at if gesture improves performance of mental rotation. So the task is to say whether the bottom figure is the same as the right figure or the left figure. Okay. So that's the task. You have to judge left or right. So in this particular example, it's the left one. That's the task. And this is a classical mental rotation task you see in cognitive psychology textbook. But we changed one thing, which is the response method. So in a classical task, people have two fingers on two buttons and say left or right. But in our experiment, we had 2 foot pedals, and the people responded with foot pedals, whether the right figure is the right one or left figure is the right one. And hands were free. And in experiments, also participants were alone in the experimental room, filmed by hidden cameras. So there is no communicative motivation to produce hand gestures, but they do produce gestures while solving this problem. And I will show you a video of of a participant who produces a gesture while solving this problem. So it looks as if the participant is grasping the object that she sees on the computer screen and tries to turn it. So people produce this kind of gesture spontaneously, even if you don't say anything about the hands, they will spontaneously do this. And the question is whether they are actually helping them to solve the problem. So we had 3 groups of participants. One group will encourage the gesture because people do spontaneously produce these gestures, but frequency is not very high. Maybe they do it in 1 in 10 to 20% of the trials. So in one condition, we encourage them to gesture every single trial. The second group were told nothing, so they were allowed to gesture, but we didn't mention it. In the third group, we prohibited people from gesturing, so people are sitting on their hands. And we gave them fixed time for thinking, and we measure the performance with error rate. And our prediction was that the gesture encouraged group should be the best. And that's what we found. So the error rate along the y-axis, so the lower the better, and 3 bars represent performance in the 3 groups: gesture encouraged group, gesture allowed group, and gesture prohibited group. And the gesture allowed group and gesture prohibited group didn't differ significantly, and I think that's because gesture frequency is not very high in the allowed group. But if you actually look at the data from the allowed group only, and compare the trials with gesture and trials without gesture, they perform better in the trials with gesture. So even for allowed group, I think there is evidence that when they produce gestures, they did better. Okay. So I think overall there is evidence that the gesture helps you to mentally rotate these objects. So in other words, gesture helps people to mentally manipulate spatial representations. The next, so that's the second function. The third function is the gesture packages information into units that are useful for speaking and thinking. And for this one, I'd like to go back to the event description, motion event description with manner path. And we asked people to describe this kind of a video. So an object is jumping up the slope. So jump is the manner and going up the path. And Dutch speakers describe 10 little vignettes like this. In this task, we manipulated the kind of gestures they produce. So in one condition, we asked people to produce separate gestures for manner and path. And in the other condition, we asked people to produce conflated gesture, a single gesture that represents manner and path. So jumping up would be like a single gesture like this. And we measured what kind of syntactic structure they spontaneously produce in the description. In Dutch, just like in English, you have an option. I mean, one clause description, like a jump up, but they could also use 2 clause description, like it went up while it's jumping. Yeah. And what we see is that the gesture has major impact on the construction choice, grammatical choice. So y-axis is proportion of trials, and left-hand side is conflated gesture condition, and the right-hand side is the separate gesture condition. And blue bars represent 1 clause description, and red is the 2 clause description. So when people are asked to produce a single gesture for manner path, most of the time they produce one close description, jumped up. But when they were asked to produce two gestures, they produced two close description. He went up while jumping. So what this means is that the gesture creates a package of information that is used for speaking. So finally, this is the fourth function, gesture explores. So when solving a problem, one needs to select the information useful for the task among many pieces of potentially relevant information, and gesture can help explore this process. And so one evidence for exploration comes from how gesture impacts the performance of the alternative use task. For example, you're asked to list all unconventional uses of newspaper. So you could say, you can roll it up and create a baseball bat, or you can use newspaper as a raincoat. And so these are unconventional uses of newspaper. And this is not my research, but this is Liz Kirk and her students' work. So they did this alternative use task under two conditions, gesture prohibited and gesture encouraged. And they found that the people generate more ideas when they are encouraged to gesture. So this tells us that the gesture is helping people to generate more ideas because they can explore affordance of the objects like newspaper. And also there is some evidence that the gesture supports trial and error at the conceptual level. So in this sort of study, we looked at the kind of gestures people produce while during the mental rotation task, mental rotation description task. So they were given two figures, like the mug study, the spiky mug study, and the people are asked to describe it verbally. And then people produce gestures. But what we noticed is that sometimes people abandon their gesture in the middle of description. So they start to raise the hand, prepares the gesture, and maybe starts to move a little bit, and then they stop and bring the hand down. So these are abandoned gestures. And these abandoned gestures, we think, tells us, reflects the sort of conceptual exploration. They're trying something, and they stop in the middle of this trial because they think that it doesn't really work. And so we carefully looked at the sort of distribution of these abandoned gestures, and they are distributed in a very sort of systematic way. So when people produce both abandoned and normal gestures within a trial, abandoned gestures tend to be produced earlier in the sequence than normal gestures. So it looks like these abandoned gestures are the initial sort of exploration of the problem. And then once you know exactly what you're doing, then you produce a normal gesture. And also, we also saw that the participants produced abandoned gestures more frequently in more difficult mental rotation problems. So that's another sort of evidence that the gestures may be doing some kind of a exploration, trial and error. And finally, I'd like to sort of share a qualitative example that shows how gesture can be driving thinking. So this is a child who is trying to explain his answer to a Piagetian conservation task. So this is a task that young children find it difficult. So so if you look at the panel A, you see two containers. One is a tall, thin container. The other one is a fat, short container. And before we get to this panel A, we showed the child that they both have the same amount of water because the short fat one actually comes from another tall thin container, and we just poured the content into the short fat one. So it's the same amount. That's what adult would say, but this child said, no, it's a different amount. The tall one has more water. Okay? And then we said, how can you tell? So this child is trying to explain his judgment. Yeah. So in panel A, the child starts to explain because and in panel B, the ball is wide. So he almost said wider, but he interrupts himself. The ball is wide because the ball is. So he's not really giving the information yet. And here, he's making a gesture that shows two aspects of the object. So width, because of this two fingers, like this. But also, it's tracing the vertical dimension of the object. So it's showing the width and height. Okay? So he's exploring both pieces of information. Verbally, he almost said wide, but he interrupts himself. And then in the third panel, panel C, he does this kind of gesture on top of the container. Okay? So movement of water as if the water is spreading out into the container. So, and then he says wider. So now he focuses on the width of the container. So somehow he abandons the idea of the height. He focuses on wide. And then in the D, he has a full explanation. It needs to fill out. That's why, the tall glass has more water. And so what's interesting about this example is that the gesture is one step ahead of speech. So in panel B already, the concept of width is in the gesture, but the full verbal expression comes in C and D. And also another interesting thing is that some features that are highlighted by gesture is not picked up by the verbal explanation. Like for example, the height of the vessel in panel B. So I think that tells you that the gesture is exploring various possibilities and verbal explanation is picking up information that that the speaker think is useful. So these kind of pieces of information, I think combined, tells us that the gesture helps explore spatio-motoric representation via trial and error. So we looked at 4 functions: activation, manipulation, packaging, and exploration. And gesture through these 4 functions affect our thinking and speaking. So we covered many studies. So let's sort of summarize what we saw today. So we looked at mechanism for gesture production and functions of gestures. So in terms of mechanism, we saw that the gestures are generated from a general purpose action generator, but it gets feedback from a linguistic process. So it's outside of the speech production process, but it's influenced by the speech production process. And in terms of function, we saw that gesture can activate imagery, gesture can manipulate imagery, and gesture can package information. And finally, gesture can explore conceptual space. So what does this all mean? So I think it has big implications for the way we think about language. So of course, linguistic communication is inherently multimodal. If you don't look at the gesture part, we don't get the full understanding of language. And also gesture is a really important window into the speaker's mind. In terms of the role of action in cognition, so these gestures are a great example of embodied cognition. Gesture influences thinking and speaking. and the spatio-motoric thinking that underlies gesture seem to complement verbal thinking. And I think this line of study also tells us why we gesture for ourselves. Because if you think about the self-oriented function, it seems like gestures are obviously useful for the audience, but if you think about the gesture themselves, it looks like, gesture may be like a waste of energy. Why would you gesture? And I think that the key is that the speech and gesture are driven by two qualitatively different kinds of thinking. So speech is driven by verbal thinking, or what I would call analytic thinking, that are based on like an abstract, like a propositional representation. And then gesture is driven by spatio-motoric thinking, the way our body interacts with space. Yeah. And so because if you produce speech and gesture simultaneously, you're thinking about the problem using two modes of thinking. So it's a bit like having two engines to fly an airplane as opposed to one. And because these two qualitatively different way of thinking about the world casts conceptual nets in slightly different areas, overlapping but slightly different areas. So if you cast these two nets, you have a broader sort of a conceptual space you can use to think about a problem. Yeah. That's why it's useful to think in two ways. It's useful to speak and gesture because you're casting broader conceptual net in the domain. So this collaboration between two modes of thinking enriches our conceptualization. That's why it's useful for us to gesture, not just for the audience, but also for ourselves. So the take-home message is that the gesture generated at the interface of action and language shapes the way we think, speak. And that's all we like to say. And I'd like to acknowledge my key collaborators in this line of thinking. And also the talk. Well, thank you very much.